we are looking at the calculator now. To do this example, you're going to need to use the statistics function. So this one here. And we've got list 1, list 2. So in the example, we need to plot a graph of this data on the GDC. So to do that, we're going to put 4, 6, 8 and 10 into list 1 and the temperatures into list 2. To do that, I just press 4, enter, 6, enter, 8, enter, 10, enter. I filled in the temperatures already just to save time. Then to plot it, we're going to want to plot a scatter graph. So I'm going to click set to see what settings I have on my calculator already. So graph 1 is a scatter graph, and that's what I want. The X list is list 1 and the Y list is list 2. That's what I want. I've put my X list, my 4, 6, 8 and 10 into X and my Y's into list 2, so that's perfect. Frequency of 1, life is good. So exit, graph 1. Now this has plotted a graph. So I've plotted a graph of this data on my GDC. That's question A. Choose an appropriate model. So that model, well, this graph is a straight line. This is where it's testing you on your knowledge of what different functions look like as a graph. And this is a linear graph, so it is a linear model because it's a straight line. So my model would be something along the lines of y equals mx plus c. If I press calc, I can then select the one that's a linear model because we have a singular x. There's no x squared, x cubed. We have other options here. We could have log graphs, exponential graphs, trigonometric graphs. So we have a linear graph, so we want x. And our graph, we're going to do ax plus b. That's the form that we know the best. So we just press ax plus b. And we get this list. And what it's saying is that our graph is y equals ax plus b. The parameters a and b have been decided by what we've inputted. The y and the x stay. So our graph is given the equation y equals 39.905 x minus 29.51. That's what this is telling us. In our next unit, we're going to look at what this R value means. So if I draw that on my graph, I can see that it fits the model really well. The straight line, our model, goes through the experimental points. So it's good. That's part D. With our graph drawn, we can now use our calculator to find the temperatures at different times. So in question F, it asks us to estimate the temperature of the water 4.5 minutes after the experiment started. So to do that, we press Shift, G solve, and the only option is Y calc. We want to find Y when we're given X. So we enter the X value of 4.5. Press enter, and at the bottom you can see here that according to our model, at 4.5 minutes, the temperature should be 150 degrees centigrade to 3 significant figures.